Jai Hind everyone, myself Rekha Baghel, Assistant Professor in Computer Science and Engineering Department, Akgec Engineering College, Ghaziabad. Today I am going to discuss a topic, backpropagation in neural network. So what is backpropagation? This backpropagation term is also known as the backward propagation. So basically this backward propagation is used to find the, or we can say backpropagation is used to minimize the difference between the actual output and the expecting output. So in this backpropagation, use the one term, that is the gradient. So this gradient is calculated by using the chain rule of the calculus, and then iteratively we update the weights of the inputs and biases because they propagates between the layers, and finally they affect the output of the network. So basically here we can see that this is a neural network. This is an example of neural network. So this is an example of the neural network. In this neural network, initially any basic neural network consists of 3 layers. Minimum 3 layers are there. So first one is input layer, second one is hidden layer, and last one is output layer. So whenever we use these 3 layers, every layer have its own importance. So input layer takes the inputs. The function of input layer is to takes the inputs from the outside entity, and next the function of hidden layer is to process that input, and accordingly they produce a output for the next layer. And after the in last layer hidden layer produces the output that goes towards the output layer. The function of output layer is to produce the output for the classification. So the number of hidden layers can be of any number. We can take hidden layers as we want. So in this example, there are 4 inputs, A, B, C, D. These are the 4 inputs, and in this example we have the 2 hidden layers, and last one is the output layer. So output layer produces the output. The hidden layers have some nodes. The number of nodes we can decide accordingly. So here in first hidden layer we are using the 3 nodes, and these 3 nodes, each node must be connected to the every input. This is the condition here. Every node of the hidden layer must be connected to the nodes of the previous layer. So here the previous layer of this hidden layer is the input layer. So each node is connected to the every input. Next, this is the second hidden layer. So the nodes of this layer will also be connected to the nodes of the previous layer. So here this node H2, 1 is connected to the each of the node of the previous layer, that is H1. Again, the output of this layer is transferred to the next output layer. Before transferring the output to the next layer, one important function is to be done here, that is the applying the activation function. So activation here, suppose for example this node is getting the inputs from these four entities. So we can say H1. So the we can first find out the sum of the inputs and biased, then we apply the activation function, so that the some probabilities, the output can be transferred in form of some probabilities. So this is the example of adjustment of the weights through back propagation. So when we reached here, we can calculate the difference between the actual output minus expected output. Okay, we find this term, and after calculating this, we minimize this difference using the back propagation. This back propagation can be divided into two steps. First step is forward pass, and second one is backward pass. In forward pass, we calculate the output, and in backward pass, we try to minimize the difference between the expected output and the actual output. So this is the first pass, forward pass. In forward pass, the input data is given to the input layer. So the function of input layer is to takes the inputs. So in first layer, input layer works. After getting the inputs, the input layer transfers this data to the next layer. So when the input layer takes the input, some weights are assigned to every input. That indicates how much particular input is having the some benefits, or you can say have the some importance. As we assign the more weights, the particular input is more important. If we assign the less weights, it indicates that the particular input is less important for the classification model. So when these inputs combined with their respective weights, which are passed to the hidden layers, now we pass the this output of this input layer to the hidden layer. Now the hidden layer, in this example we have the two hidden layers, hai na? So in this example we have two hidden layers, H1 and H2, and the number of nodes of every hidden layer we can decide, but condition is, so nodes of every hidden layer must be connected to the every node of the previous layer. Okay, now previous layer and the next layer. So here, so before applying an activation function, a bias is added to the weighted inputs. So now bias is added. So now we can calculate the output of hidden layer in this form, like xi wi plus b, I is equal to 1 to n. So here xi wi means xi is the input, wi is the weight associated with particular input, and b is the biased. So we can calculate this. After calculating this, we find some output. We can say it's a. Okay, we can say weighted sum, it is a. Now we can apply the activation function as per our requirement on this a, so that we get the value according to our requirements. So this is the each hidden layer computes the weights of the inputs and then applies an activation functions like ReLU, rectified linear unit, to obtain the output. Now when we obtained this output is forward to the output layer. So this where an activation function like softmax can be used to convert the weighted sum to the probabilities according to the classes we have. So this is the procedure of forward pass. So when we reached at this point, so forward pass completes when we reached this point, means output layer, and the output is produced in form of some probabilities, and accordingly we can classify the classification task is done. Now we calculate the difference between the output, expected output and actual output. When this difference is when there is any difference, then we try to minimize this difference by using the forward pass. By using the backward pass. So this is the backward pass. In backward pass, the error that is propagated back through the network to adjust the weights and the biases. So we have assigned some weights through the inputs, and biases are also assigned, and based on these terms we calculate the output. Now we update the weights so that if we have wrongly assigned some weight to the particular input and it is not participating to the getting the real output, so we can minimize the weights. So this first we calculate the error. For calculating the error that has done by our neural network can be calculated by using the MSE, mean squared error. So this mean squared error is calculated through predicted output minus actual output whole square. So once this error is calculated, we change the weights using the gradients with the help of some chain rule, and these gradients indicates how much each weight and bias should be adjusted to minimize the error in the next iteration. So backward pass, first the output layer. This backward pass continues layer by layer, ensuring that the network learns and improves its performance. First, we update the weights of the just before the layer, just previous layer of the output layer. After that, we update the weights of the previous layer of the second layer, means we move in this direction. This is the network. In backward pass, what we have done, we first update the weights of this layer, then we move towards this direction, then with the help of this we update the weights of this layer, and after that we update the initial weights here. So this is the backward direction. So we move in backward direction. We can understand all this concept by using some example. So this is the example. Suppose we have a neural network. In this neural network, sigmoid function is used for forward and backward directions, forward and backward pass, and we assume that the target output value is 0.5 and the learning rate is 1. By using this values, we need to update the weights. This is the neural network. So in this neural network, what we have given, these are the two inputs, x1 and x2. The value of x1 is 0.35, value of x2 is 0.7, and the weight of this is weight x1 0.35 with the h1 is connected to 0.2, and the in this direction weight is connected 1.2, and this is 0.2 and 0.3. Okay. So all the nodes which are connected to the H1 having the weight 0.2 and all the nodes connected to the H2 node is 0.3. So now we will calculate the updated weights so that the difference between, so that the MSE can be minimized. So first step is initial calculation can be done by calculating the weighted sum at each node. So this formula is there. We have not provided any biased here. So this B term is missing here. So we will calculate the weighted sum by using the formula W suffix I comma j into xi. So here xi is the inputs, wi is the weights between the ith input and the jth neuron, xi represents the value of the ith input. So Oj is the final weighted sum and O is the output after applying the activation function to get the output of the neuron. So Aj is equal to activation function, O is equal to activation function A of j. So now we apply the sigmoid function. So the sigmoid function returns a value 0 and 1. So these activation functions are used to apply the non-linearity into the model. So this sigmoid function can be defined as yj is equal to 1 upon 1 plus e raised to the power a. Means whatever the weighted sum we have received, means this sigmoid function we are calculating here, if the output from the previous layer is calculated by using the xiwi. Now we apply the weighted sum of this Aj. Now we apply this Aj, we are giving this Aj to the some activation function, sigmoid activation function 0 and 1, and we apply here. Now next we have these to the this one second layer, okay, hidden layer. So we calculate activation function. So we calculate the output at H1 node. This H1 node, we calculate the output like W1 X1 plus W2 X2. So we have already calculated this point, means Xi Wi. We have already calculated this. So 0.35 into 0.2 plus 0.7 into 0.2. So this is calculated 0.21. Now we have calculated this. So this calculation we apply here and apply the activation function here. So we calculate the value of 0.56. So 0.56. We calculated this. After this, we calculate the value of A2. A2 means this one. 0.3. 0.3 into 0.35 plus 0.7 into 0.3. Okay. So this is calculated. So we get 0.315 and we apply the activation function here. Activation function is this, and we get the value of this here. Okay. Now we get the value of this. And now y5. So we have these are the weights and these are the input values. So xiwi and xiwi. So we can calculate this 0.3 into 0.3 into 0.57 plus 0.59 plus 0.9. So we get the value of 0.702 and apply the activation function, we get the value of 0.67. So this is the forward pass. Still we are calculating the values for the forward pass. Now we reached at this point. The output we received. The output we received is 0.67. This point, the output we have received 0.67, and initially the target output is 0.5, and our model calculate the output of this classification model is 0.67. So there is a difference between the expected output and the actual output we are getting now. So we calculate the error y target minus the output produced by the output layer. So this is 0.5 minus 0.67 is equal to minus 0.17. This is the error that our model produced. So by using the back propagation, we minimize this error. So this for minimizing the error, first we need to calculate the gradients. So gradients can be calculated by using this formula, where delta is the error term for the each unit, eta is the learning rate. So output, first we calculate the output unit error done by at the output layer. So this is we calculate the delta error term. So this is the formula we apply. The output produced by particular layer into 1 minus output produced by a particular layer, and the expected output minus output produced. So this is the we get this output. Now we will calculate. So in this we calculate the gradient from the output layer. Now we move towards hidden layers. Okay, hidden layers. After that we move towards input layer. Okay, so at hidden layer we calculate the gradient for the node 1, or you can say H1. So this is the delta 3. So delta 3, Y3, it is producing the output Y3, 1 minus Y3, and gradient into, means we are updating the weights. So we apply this, means this weight is now changed with respect to the gradient of the next layer, means output layer have produced some gradient. This gradient is this value of this gradient is multiplied to the weight of the previous layer. So this is the weight, and apply this. Accordingly, we calculate the unit error of the node of H2. So delta 4 is equal to Y4, 1 minus Y4 weights, and this one. We calculate the delta 4 value is this. Now weights are updated. So for the weights from hidden to output layer, weights W23 is equal to 1 into this is the and this. So we can calculate this, and after that new weights are this one. Okay. Now weights from input to hidden layer can be calculated by using this. New weights are this. So similarly we can calculate all the weights, and now we calculate the output produced by this neural network by using the updated weights. So we can calculate the new way, we can calculate the outputs produced by the each layer, and after that we come to the final output produced by this output layer. So output produced by this one is now 0.57, the output produced by this node is 0.56, and finally the output produced by using these updated weights are like 0.61. So 0.61 is still not the targeted output process. So still we have not reached to the expected output. So what can do now? So this back propagating continues until the desired output is not reached. So we apply the back propagation again and again until we reach to the expected output. So it's we cannot reach exactly the expected output, but we can reach nearby this. So error, we can calculate this error. 0.5 minus 0.61 is equal to minus 0.11. So we have this error. So this process is continuous till we get the expected output. So this is the all about the back propagation. So I hope all of you have understand what is the back propagation now and how it can be applied to minimize the error between the expected and actual output. So this is all about back propagation. Thank you.